Hello and welcome to this tutorial on model management with RapidMiner's Model Operations. We are going to focus exclusively on the management of already deployed models and deployment monitoring. If you need details on how to create deployments and deployment locations, or if you are seeking a brief overview on RapidMiner Model Operations, then please refer to our other materials. Alright, let's jump right in. Here, you see the overview page for this remote deployment location. It contains two classification deployments, of which one is active, as indicated by the green circle. Active or inactive, in the context of an entire deployment, means that active deployments run the alerts checker and have web services associated for scoring and the upload of actuals. Speaking of alerts, you can see the number of alerts which were triggered per deployment, but also summarized for the entire location. Now let's dive into this active deployment and explore the models which were added to it. Each model that was added is shown with its name and the type of the model. We see the creation date and who was the author, which means that you can see here who added this model to the deployment. And now you can already see why we are using a remote location for this demo. Multiple users can be connected to the same deployment location, which means also multiple people can configure the deployments that it contains. A good thing to know in this context is that each deployment will only accept the addition of fitting models. This means that if someone tries to add a model which was built on a dataset that was different in its structure compared to the existing ones, or is maybe even a regression model where the current deployment has classification models, then this is going to be rejected. The next column indicates the status of the models in this deployment. The active model is at the top, and challengers, or inactive ones, are listed below. You can change that easily here. Now, what is the difference? The active and the challengers are always executed when new data is scored. The inactive ones are not. Similarly, the performance is checked for active models and for challengers. Now, the difference between those two is threefold. Only the active model's scores can be exported when scoring is done through the Scoring tab. Only the active model is monitored and alerts get triggered. Finally, but most importantly, when the deployment as a whole is activated, then only the predictions done by the active model are returned through a web service. Challenger models, on the other hand, are also used for generating the predictions in the Scoring tab or via the web services, but those predictions are only used for calculating the performance of those challengers to see if they potentially beat the active model. Then the next columns of the table show you the error of the model during its development, followed by the recent error, which is the error rate for the time range currently selected. This is useful to compare the models among each other, but also for comparing with the pre-deployment error. If the two error rates are diverging from each other, you might experience drift in your input variables, or a so-called concept drift, where your prediction is not accurate anymore because the world has changed. For flight on-time predictions, this may be due to changing measurement and reporting of delays, so a drift in your input variable. For customer loyalty predictions, it may be because your consumer's behavior has changed due to a new technology. The other really important thing you can do on this tab is to click on each model to see its full details. You can see the actual model, the data which was used to train it, the process which we generate to build it, and here are all the other results which have been archived during model creation. This is very helpful and required in the context of compliance and governance. Alright, now we close this, and with a look at the last column, which shows us the average response rate per 1,000 scores, we return to the dashboard of this deployment, and right here, you can see the same numbers for error rate and response time, so now you know they do only refer to the active model in the selected time frame. We cover batch scoring and scoring through a web service elsewhere, so I won't address these here, but we will see where gains and alerts info come from, so let's jump into performance next. Okay, this is the heart and center of the model monitoring and the actual model operations. Let's start at the top here where you see the currently active model of this deployment. The chart below shows the total number of scores for the active and challenger models, and right next to it, you can see how each of the model's error rates have been changing over time. In case the rates increase over time, you should keep a close eye on them and consider updating or replacing your active model. Now, on the overview, you saw only the scoring time for the active model, but here they are shown for all models which are active or challengers, and in cases where speed is crucial, you can use this to assess if you want to switch to a slightly worse performing model in exchange for faster replies. The next two charts show the actual and the predicted class distribution, which is very helpful for the assessment of your predictions. When you are only looking at the error rates, you can't tell if your model is overly optimistic or pessimistic, but from this chart, you can see what kind of behavior for each class is favored. The results could also be an early warning of a concept drift happening, but most likely it is a consequence of the cost matrix we defined during the model training phase. And since I have just mentioned it, let's jump into that topic for a moment. When you look at this matrix, you can see that predicting a flight to be on time and then have it arrive late is the most costly of all options, whereas predicting a late arrival and actually have an on-time one is much cheaper, so that's what the model favors. Now, this matrix is defined during the model development, and so changing it here has no effect on the two charts which we just looked at, as all these predictions were done in the past and won't be changed, but you can use them for a what-if test on the gains. So, let's see how this chart down here connects model operations and business by directly showing you the value of your predictions. We have two available options, which is on time and delay. We have two ways to react to these, which is we prepare for a late arrival or we don't. If we prepare for a late arrival, then we are creating some cost which eats our profit, but in case of a delayed arrival, they help us to reduce the loss. The best case is to have an on time with no unnecessary preparation, and the worst case is a delay without any preparations. We know that about 60% of our flights are delayed, and only 40% arrive on time, and so we will do this scenario for 1,000 flights. Now, here's how this would play out for a perfect world where we always prepare or not in the right way. In that case, we would create a loss of 2 million. Since we don't know what is going to happen, our situation is worse because we have to decide to always assume a late arrival and prepare, or always expect on time and do nothing. As you see, the yes and the no case create a loss of 8 million. In this specific case, it does not really matter if we lose the same amount in both scenarios. In most situations, one default option is better, and that one is typically already implemented in your organization as the current behavior. Now, 8 and 2 million are the bounds, so how does our model compare against these bounds? If we act according to the predictions, then we can significantly reduce our loss to 4 million, which means a gain of 4 million against the current best choice. We are still losing money due to delays, but thanks to being aware and able to prepare accordingly, we have reduced our losses significantly. If we would manage to reduce our preparation cost by 50% from 15,000 to 7,500, then we could even turn this loss into a profit with the help of our predictive modeling. Okay, now this is exactly what this graph shows added up over time. When I adjust the numbers in our cost matrix to account for our cost savings, you can see how the graph adjusts and shows us what difference this model made or could have made. And this here is the essence of what value machine learning can bring to the table. It is really not about accuracy or AUC or anything else, but it is about value and improving or even automating decision-making. The two remaining parts to this video are about making sure that this impact is kept going over time, so we have drift and alerts left to talk about. Drift was alluded to before. The drift monitoring here is checking the input data we are getting in production and compares it to what we had during training time. So, in this tab, you can just click on the chart down here and see, for example, what the mix of carriers was in our training as compared to our in-production time. The strongest drift is here in this delay, which may be due to new regulations or changes in the logistics. Now, a strong drift may not be so bad if it is a variable which is not that important for the model. But how would you know? For that, we have this other option here, which tells us about the importance of a certain attribute and its drift. If an attribute is far to the right and has a high drift, then you should worry. But if it is on the lower end of the importance spectrum and shows a bit of a higher drift, then this is not so concerning. As you can see, our drifts are rather small across attributes with varying levels of importance. Alright, now from a really useful feature. You are not only expecting insights, but also that it makes your life easier. And so we did not only create options to monitor your models, but we also enable you to automate this monitoring. This is where alerts come in. Alerts are very important, so you will see them on the location dashboard, the deployment dashboard, and of course in full detail on the Alerts tab. Just as a reminder, for alerts, you need both a remote deployment location and monitoring activated, and the deployment itself needs to be activated as well in order to have the alert checkers run. To set up email alerts, please make sure to specify a connection for sending emails when you add the deployment location. Similar to the monitoring connection, the email connection needs to be stored in the same repository you are using to store all deployments and models. You can see here that there are 3 alerts already set up. One is associated with an email, so every time it is triggered, an email will be sent, and it will look similar to this. Setting up the alerts is straightforward. You can select one of the triggering options and then fill in the details like the threshold for a trigger, how often the alert condition is to be checked, and what the reference time frame should be. With the right mouse button, you can select to test your new alert immediately, or you can use it to delete one. The Notifications section shows the alerts which have been triggered, and they are grouped. So, if one of your alerts has been triggered multiple times, you won't see a long list, but the count would increase. They are shown here until you acknowledge them either one by one or all at once. Alright, this is model management and monitoring in RapidMiner. In this video, we showed you how you can explore and interact with your models, how you can monitor your deployments, how you can keep track of individual parameters, but also how to identify the overall value of your predictions. Thank you very much for watching.